Okay, here we go onward and forward. So we have number 16, and the common denominator is 3x. So basically the LCD is 3x, and I'm going to multiply that everywhere. So let's see how I can do this. 3x over 1 times 8 over x plus 3x over 1 times 1 over 3 equals 9 over x. Whoops. 9 over x. Let's see. Equals 3x over 1 times 9 over x. There we go. Okay, so cancel, cancel, cancel the 3's, the x's. There we go. Now we should have canceled all the denominators out. So 3 times 8 is 24 plus. All that's left here is an x. That's nice. And all that's left here is a 27. My goodness, I can already see the answer in the multiple choice options. It's 3. Great. Okay, so what did we do? We found the LCD, then we multiplied by the LCD, then we canceled stuff, and then we solved. Alright, that was actually a relatively easy one, so be prepared for one with maybe a little more work. Okay, number 17. Write the first n terms. Great. So what we want to do is say that the first term is term number 1, and then term number 2 and 3, and it looks like by the time we get to that many, we'll have our answer. Okay, so we plug a 1 in to find the first term. So 1 times 5 is 5. 5 minus 4 is 1. So that means A is wrong and D is wrong. Now let's try it again. We plug a 2 in. 2 times 5 is 10. 10 minus 4 is 6. So, bammo. Answer choice C. I'm not even going to find anymore. Who cares? Okay, let's see here. Write a rule and find the fifth term. Alright, this says geometric, arithmetic, arithmetic, geometric. Those are the words. But if you look at this, all of these answer choices are geometric looking. Geometric. Okay, so I know it can't be arithmetic because it is obviously geometric. Okay, now the rule is either 3 to the n minus 1 or it is 3 to the n. Well, think about that. Position 1 is a 1. Position 2 is a 3. Position 3 is a 9. Position 4 is a 27. In this one, if you plug this 1 in for n, so you get 3 to the 1, is 3 to the 1 1? No, sorry dude, it's not. So that's not our answer. So our answer is answer choice A. You can check it if you want. If you plug a 1 in, 1 minus 1 is 0. 3 to the 0 is in fact 1. Okay. Write a rule, find the fifth term. Hey, I'm going to say the same thing to you again. Look at these answer choices. They're all geometric answer choices, which means it's not arithmetic. Not arithmetic. Okay. Okay, so it's geometric. So now that we know that it's geometric, there we go. We just do that same test we did just a minute ago. We know that the first term is supposed to be a 1. The only one that's going to give us that is B. Done. Okay, find the sum. Oh, it's geometric, and we're going to need to know the cheat sheet. See what this is. So let's see if I can find the sequences in series cheat sheet real quick. You should be looking for your cheat sheet. I can be looking for my cheat sheet. We can all find it. It's in here somewhere. There it is. We'll come back here. Hey, I did not want to go to the App Store. I don't know how to get out of this, guys. There we go. Okay, so this is a geometric. So come to sequences in series and look for the geometric rule. Right here, the sum of a finite geometric series is the a sub 1 times 1 minus r to the n over 1 minus r. Alright, so let's get back in here. A sub 1, 1 minus r to the n over 1 minus r. Okay, well you can see that the first term is 10. 1 minus, that's negative 4 to the 5 is the n, all over 1 minus negative 4. You're going to enter this into your calculator. You're going to have to go really carefully. So you're going to do 10, open parentheses, 1 minus, open parentheses, negative 4, close parentheses, caret key, 5, close parentheses, divide key, open parentheses, that's a divide key, open parentheses, and 1 minus, open parentheses, negative 4, close, close, close. Goodness gracious. Press enter. You loving that kid music? She's only 9 months, but she knows how to make the toys sing. Okay, it says find the sum of the infinite series if it exists. Well, what would make it not exist? Let's see here. It is times 2 times 2 times 2. So it's times 2 each time. Go to your sequences in series. For an infinite, it says if the rate is less than 1, you've got a sum. If the rate is greater than 1, the series has no sum. This is times 2 each time. Times 2 is greater than 1, so no sum exists. Okay, write a recursive rule. Remember, recursive rules are based off of the first term. In this case, the first term is 4. So this answer is correct. This answer is correct. So D is wrong and B is wrong. Alright, so basically the question comes down to, are we subtracting 9 or adding 9? Obviously we're adding 9. So the answer is C. Remember that a sub n minus 1 scariness is the same as saying the word previous. Okay, solve triangle DEF. Well, where do we draw our person? Do you even remember where the person goes? The person always goes at the angle. So this is our hypotenuse because the hypotenuse is across from the right angle box. This is adjacent because it's our next door neighbor. And this is the O because it's on the other side of the street. Okay, so what we have then is the hypotenuse. So if I have so, ka, toa, I know for this problem I'm going to use sine and cosine. Okay, so the sine of 21 is equal to the opposite, which is letter D, over the hypotenuse, 14. So bring that 14 up, and you get 14 sine of 21. Okay, let's see if I can do that. 21 sine 21 times 14, telling me 5.01. Is that an answer? Yeah, right here. Well, I can't circle it. There we go. That is the only one with the correct answer choice for sine. So we could stop the problem right there. You can move on, or you can do cosine of 21 equals adjacent over hypotenuse. So 21 cosine times 14. 21 cosine times 14. And that's 13.07. And hey, that's the same answer. So sure enough for C, we got it. Now the question is, how did they get 69? Well, 21 plus 90 plus what makes 180? Because remember, triangles add up to 180 degrees. So that's how they got 69. Alright, coterminal. Oh good, I like these. So you start by drawing what you have. So this is 270, so 284 is like somewhere right here. Okay, now to find a coterminal, you can either go all the way 360 and back to it, so 360 and another 284. That would be coterminal. So that's 14, right? Yep, 14. Add 1. 4, 6, 44. Aha, we already found the answer. Okay, now just for your information only, coterminal could also be going backwards, which would be 360 minus 284. So that's a 6, 2, 15. That would be 76 degrees in the negative. So you could go negative 76, you could go down, negative 76 and be coterminal, or you could go around one whole time and then again 284 to be a positive 644 degrees coterminal. That's positive degrees, and we're done. Okay, I'm going to make a new video.